This slide presents the overview of the chapter. Learning objectives. By the end of this chapter, you will be able to
represent the numbers on the number line, analyze the operations of integers under addition, subtraction, multiplication, multiplication of two negative integers, multiplication of more than two negative integers, division. Define the properties of integers under addition, multiplication, subtraction, division.
Introduction. Before entering into the chapter, follow the instructions shown on the screen. Click each tab to know more.
We know in lower classes we studied numbers like 1, 2, 3, 4 and so on for counting objects around us. These numbers are called natural numbers. If we add 0 on the number line, we can get the new collection of numbers called whole numbers. The numbers which are behind 0 are called negative numbers. Now, it is wholly called as integers. We already studied about integers and their properties. Do you know the operations of integers under addition, subtraction, multiplication and division and their respective properties? Let us know. So, in this chapter, let us discuss about the various operations of integers under addition, subtraction, multiplication and division along with their respective properties. Let us perform an activity on marking of integers on the number line. Mark the numbers on the number line starting from smallest to biggest number among the following. Note: on a number line, the number increases as we move to right and decreases as we move to the left. Therefore, ascending order of the given numbers is -7 less than -5 less than 3 less than 5. For the given numbers, the ascending order representation is -7, -5, 3 and 5. Ascending order of the given numbers is -10 less than -8 less than 4 less than 6. For the given numbers, the ascending order representation is -10, -8, 4 and 6. Ascending order of the given numbers is -8 less than -5 less than -1 less than 2. For the given numbers, the ascending order representation is -8, -5, -1 and 2.
Let us solve a few exercise problems. Click the tab to view solution.
Let us learn about the operation of integers. Operation of integers includes addition, subtraction, multiplication and division of integers. Let us review the addition of integers on a number line. If we add positive integers to a number, you will move to the right side of the number line. If we add negative integers to a number, you will move to the left side of the number line. Take a number 5 on a number line and add positive integers 2 and 3 to it. We observe that the obtained numbers are right side to the number 5 and they are 7 and 8. Similarly, take 4 on a number line and add negative integers -1 and -3 to it. We observe that the obtained numbers are left side of the number 4, that is 3 and 1. Let us do an activity to represent the addition of integers on a number line. Note: when we add positive integer to the number, the obtained number will move to the right side of the number line. Its representation is as shown on screen. Its representation is as shown on screen. Note: when we add negative integer to the number, the obtained number will move to the left side of the number line. Its representation is as shown on screen.
Let us solve a few exercise problems. Click the tab to view solution.
Let us learn about subtraction of integers. Take a number 3 on a number line and subtract positive integers 2 and 3 from it. We observe that arrow is moving to the left side of the number line. Take a number 4 on a number line and subtract a negative integer -2 and -3 from it. We observe that the arrow is moving to the right side of the number line. Let us perform an activity for representing subtractions on a number line. Note: for the given number, when we subtract the positive integer, the obtained number will be left side of the number line. Its representation is shown on screen. Note: for the given number, when we subtract the negative integer, the obtained number will be right side of the number line. Its representation is shown on screen. Its representation is shown on screen.
Let us solve a few exercise problems. Click the tab to view solution.
Let us now learn about multiplication of integers. We already know that multiplication of natural numbers like 5 into 2 equal to 10. Here we added 2 for 5 times. Its number line is represented as shown on the screen. We do the same for product of 2 and -3. We obtain its result as -6. Here we are going to add -3 for 2 times. Its number line is represented as shown on the screen. Let us observe the multiplication of integers. Multiply the numbers on the number line with 4. We will obtain -20, -16, -12, -8, -4, 0, 4, 8, 12, 16 and 20. So, we observe that the difference between each successive terms is the same, that is 4. Similarly, by multiplying the same number line with -3, we obtain the numbers as 15, 12, 9, 6, 3, 0, -3, -6, -9, -12, -15. Again, we observe that the same difference is existing between each successive terms, that is 3. From the above two observations, we can conclude that the product of one positive integer and one negative integer is always a negative integer. Rules of multiplication of integers. The product of two positive integers always is positive. The product of two negative integers always is positive. The product of one positive integer and one negative integer always is negative integer and vice versa. Let us do a simple activity to choose the correct option for multiplication of integers. Choose the product of a positive integer and a negative integer always is a negative integer. The product of two negative integers always is a positive integer. Let us further discuss about multiplication of more than two negative numbers. Let us assume the numbers -3, -4 and -5 and multiply them as shown on the screen. As we know that product of two negative integers is a positive integer. So, first multiply -3 and -4. Thus, we obtain it as 12. Then, multiply the resultant number 12 with -5 and its product is obtained as -60. In this way, we multiply many negative number of integers. Let's see some examples of multiplication of more than two negative numbers. By these examples, we can observe that if the number of negative integers being multiplied is even, then the obtained product is a positive integer. If the number of negative integers being multiplied is odd, then the obtained product is a negative integer. Let us now perform an activity to know the multiplication of more than two negative numbers. Drag the suitable answer from group B for group A and drop it in boxes. The product of even number of integers is always a positive integer. The product of odd number of integers is always a negative integer. Here we are going to discuss the multiplication of two or more numbers in an easier way. In our previous classes, we learned how to multiply the two given numbers, say 20 and 32. In general, we do multiplication as shown on screen. The easiest way to do multiplication for the above given numbers is as follows. First, write the number 20 as usual, and for easy solving, write the number 32 as 30 plus 2. Now multiply 20 with 30 plus 2. We get as shown on screen. Similarly, to multiply the numbers 20 and -98, write the negative 98 as -100 plus 2. And
let us solve a few exercise problems. Click the tab to view.
Now, let us study about the division of integers. Division is nothing but the inverse operation of multiplication. We know that the product of 5 and 4 is 20. Therefore, the inverse of it is 20 by 4 is equal to 5, or 20 by 5 is equal to 4. So, for every multiplication statement of natural numbers, there will be two respective division statements. Let us see some examples on division of integers. From the above table, we conclude that we get quotient as a positive integer when we divide two negative integers. let us have a look on rules of division of integers. If two positive integers are divided, we get positive integer as quotient. If two negative integers are divided, we get positive integer as quotient. If we divide one positive integer and one negative integer, we get negative integer as quotient and vice versa. Let us perform an activity on the division of integers. Select suitable answer from group B for group A and drop it in bracket provided against A. Here, we will learn about the properties of integers under addition. Properties of the integers under addition can be categorized as closure property, commutative property, associative property, additive identity property, additive inverse property. Click each tab to know more. Closure property defines for any two integers a and b. A plus b is also an integer. In the first statement, minus 9 plus of minus 8 is equal to minus 17. It concludes that the sum is an integer. In the second statement, 9 plus of minus 8 is equal to 1. It concludes that the sum is an integer. In the third statement, minus 12 plus of minus 12 is equal to minus 24. It concludes that the sum is an integer. Therefore, the above table follows closure property under addition. Commutative property defines for any two integers a and b. A plus b is equal to b plus a. The second statement, 2 plus 5 is equal to 7. And it concludes that a plus b is equal to b plus a. Same for the second and the third statements also as shown in the table. Associative property defines that for any three integers a, b and c, a plus of b plus c is equal to a plus b plus c. In the first statement, 1 plus of 3 plus 2 is equal to 6, and in the second statement, 1 plus 3 plus 2 is equal to 6. And it concludes that a plus of b plus c is equal to a plus b plus c. Additive identity property defines for any integer a plus 0 is equal to 0 plus a is equal to a. In the first statement, minus 9. In the second statement, 0 plus of minus 9 is equal to minus 9, and it concludes that a plus 0 is equal to 0 plus a is equal to a. Additive inverse property defines that for any integer a, there exists an integer minus a such that a plus of minus a is equal to 0. Both the integers are called additive inverse of each other. In the first statement, 5 plus of minus 5 is equal to 0. And it concludes that a plus of minus a is equal to 0. Same for the second and the third statements as shown in the table. Therefore, the above table follows additive inverse property under addition.
Knowledge check. Attempt the following questions to check your understanding.
Here, we will learn about the properties of integers under multiplication. Properties of integers under multiplication is categorized into closure property, commutative property. Click each tab to know more. Closure property defines that if a and b are two integers, a into b is also an integer. In the first statement, -9 into -8 is equal to 72. It concludes that the product is an integer. In the third statement, 12 into 1 is equal to 12. It concludes that the product is an integer. Therefore, the above table follows closure property under multiplication. Commutative property defines that for any two integers a and b, a into b is equal to b into a. In the first statement, 5 into 2 is equal to 10, and in the second statement, 2 into 5 and the third property under associative property defines that for any three integers a, b and c, a into b into c is equal to a into b into c. b into c is equal to a into b into c. Same for the second and the third statements as shown in the table. Therefore, the above table follows associative property under multiplication. Distributive property defines for any three integers a, b. In first statement, 1 into 3 plus 2 is equal to 5, and in second statement, 1 into 3 plus 1 into 2 is equal to 5, and it concludes that a into b plus c is equal to a into b plus a into c. Same for second and third statements. Multiplicative identity property defines that for any integer a, 9 into 1 is equal to -9, and in the second statement, 1 into -9 is equal to -9, and it concludes that a into 1 is equal to 1 into a is equal to a. Same for the second property. Multiplication by zero property defines that for any integer a into 0 is equal to 0 into a is equal to 0. In the first statement, -9 into 0 is equal to 0, and in the second statement, 0 into -9 is equal to 0, and it can. Let us do a lab activity on the properties of integers. The objective of this activity is to state and illustrate the different properties of operations on integers. The materials required for this activity are a few mangoes, apples, and bananas. Let us assume mangoes represent A and apples represent B. The correct numerical values of the mangoes and apples are noted in the given fields. Here, as both LHS and RHS are equal, we observe that the figures are representing commutative. Let us check for the associative property under addition. Let us assume mangoes represent A, apples represent B, and bananas represent C. The correct numerical values of the mangoes and apples and bananas are noted in the given fields. Let us check for the distributive property under multiplication, and mangoes represent C. The correct numerical values of the mangoes and apples are noted in the given fields. Let us check for the additive identity property under addition. Let us assume apples represent A. The correct numerical values of the apples are noted in the given fields. Here, the above observations can be represented in a tabular form as shown. Integers satisfy commutative, associative, distributive, and additive identity properties under multiplication and addition.
Knowledge check. Attempt the following questions to check your understanding.
Here we will learn about the properties of integers under subtraction. Among all the properties, subtraction follows only closure property. Closure property defines for any integers a and b, a minus b is also an integer. In the first statement, 10 minus 9 is equal to 1, and it concludes that a minus b is an integer. Same for the second and the third statements as shown in the table. Therefore, the above table follows closure property under subtraction. Properties of integers under division. Let us see whether the following properties satisfies the integers under division. Click each tab to know closure property is not followed under division. In the first statement, minus 10 by 5 is equal to minus 2. It concludes that it is an integer. In the second statement, when 3 is divided by 6, the obtained result is 1 by 2, which is not an integer. Similarly, the last statement is not an integer. The above table shows that the closure property is not followed under division. Commutative property is not followed under division. In the first statement, minus 10 by 5 is not equal to 5 by minus 10. It concludes that a by b. Division by 0 is also not a property under division. In general, for any integer a by 0 is not defined, but 0 by a is equal to 0 for a not equal to 0. So, we conclude that anything divided by 0 is not defined. And 0 by any number is always 0. Its example is shown on the screen. Any integer divided by 0 is meaningless or undefined, and 0 divided by n. Division by 1, in general, for any integer a by 1 is equal to a. For example, 2 by 1 is always 2, which concludes that a by 1 is equal to a. Similarly, the next two statements conclude the same. The above table shows that if any positive integer or associative property. In general, associative property is not followed under division. Here, in the first example, initially divide 4 with 2. We get 2. Thus 8 by 2 is equal to 4. Similarly, in statement 2, initially divide 8 with 4. We get it as 2. Thus 2 by 2 is equal to 1. Thus we conclude that a by b by c is not equal to a by b by c. Similarly, the next two statements are shown. Let us solve some example problems. A person climbs up 6 stairs every second and climbs down 2 stairs the next second. Find the number of seconds required to climb 40 stairs. Solution. Given number of stairs climbed up in 1 second equal to 6 and number of stairs climbed down in 1 second equal to 2. Total number of stairs are 40. Total number of stairs climbed up in 2 seconds is equal to the difference between number of stairs climbed. It went plus increase in temperature in the morning plus increase in temperature in the afternoon minus decrease in temperature in the evening. Final temperature is equal to minus 4 plus 3 plus 2 minus 1.5, which is equal to 5 minus 5.5, further equal to minus 0.5 degrees centigrade.
Let us solve a few exercise problems. Click the tab to view solution. Try to solve the problems in the practice zone on your own. You can click solution for your reference. Summary. Let us recap the highlights of this chapter.
We move to the right on the number line if we add a positive integer. We move to the left on the number line if we plus c is 9. Closure property is satisfied in addition, subtraction and multiplication. Commutative property is satisfied under addition. That is, a plus b is equal to b plus a. That is, a into b is equal to 0, for a not equal to 0. For any integer a by 1 is equal to a. To make our calculations easier, these type of properties are very helpful.
Let us list out formulas involved in this chapter.